after we have looked into some of the basic formulas and the concepts of straight line, we'll now look into how to form the equations of straight line. We haven't yet talked about how to form the equations of straight line and what does it look like. So in this particular next segment, we'll look into how to what are the different forms of straight line and how to visualize these straight lines. So the first form which we look into is that of the point slope form. So let's say we have a particular line L1 on which we are being given a point A and the slope, that is, say, M. This is the foremost and the simplest one. We'll derive other results based on this only. So let's what we'll do is that we'll take a general point Px comma y and calculate its slope with the point A as the second point. So we can easily calculate the slope of the line by y minus y naught upon x minus x naught, and we'll equate this particular slope to the given slope to obtain the equation of the line as y minus y naught is equal to m into x minus x naught. In any textbook of in which straight line is discussed, you will find this is given in a very tedious way, but we'll work out other forms from this particular form itself. Okay, so next particular form is that of the 2-point form. So as the name suggests, we'll be given we'll have the knowledge of 2 points which lie on the particular line, and we have to find the equation of the line. So to do that, what we'll use here is that we'll convert it into the problem of the earlier one. That is, we can convert it into the form in which we have given 1 point and a slope. So the slope can be calculated easily by seeing that we have been given 2 points and just using these 2 points to find the slope of this particular line. So to use these points, we have, let's say, this line, we have B, x1, y1, and say A, x0, y0. So you can easily calculate the the slope by this formula of the slope. Just use the formula. We'll have y1 upon minus y0 upon x1 minus x0. So we have the slope here and a point. Let's take the other point as A. So now it is converted to the earlier equation in which we have the m, which is equal to y1 minus y0 upon x1 minus x0, and the point. So let's take the point as A x0 y0. Then we can write the equation by using the earlier result of the point slope form as m equals to y minus y0 upon x minus x0, and m is by equating this we have this particular equation. We don't need to memorize it. You'll get it by practice, and it will be easier for you if you just go by the basic conceptual part here. Just get the slope, just concentrate on finding slope somehow, and a point to finding the next one, which is the slope intercept form. In this particular form, we are given a point that is that lies on the y-axis when the line intersects the y-axis, that is A whose coordinates are 0, c, and the slope, that is this particular theta. So to calculate this, it's easier. As you can see, it is same as that of the first form, in which you have been given the value of m and the point, say A equals to 0, c. So to calculate the this particular form of the straight line, we'll have, so you can see, as you can see, this is the same as the first form. We have the point A 0, c and the slope. So we'll equate the slope m is equal to the slope of the line passing through P and A. To just slide the slope using the slope form for P and A, we have y minus c upon. So as you can see, we'll write the slope, which is equal to y minus c upon x minus 0. And after simple manipulation by multiplying x here and taking c, we have this particular form. This, as you might guess, is the simplest form to write an equation. Just get the slope, just calculate the slope, and put the value of the y-intercept. Next is that of the intercept form. Earlier you were given only the y-intercept. In this particular form, you are given 2 points in the form of intercepts. And what are intercepts? They are basically the points at which the line cuts the x-axis and the y-axis. So when the line cuts the x-axis, we have x-intercept, and when the line cuts y-intercept, we y-axis, that we have y-intercept. So let's we are given 2 points. Say a equals to a comma 0 and b equals to 0 comma b. So it's just, as you can note, that is the second form of the equation in which we are given 2 points, say a and b, and we have to calculate the line of the equation of the line. So here also what we'll do is that we'll calculate the slope using the given information, that is these 2 points, and equate that to the that of the slope by taking other point as p and b. So first of all, let's see what is the slope of the line passing through a and b. We'll have 0 minus b upon, so we'll have the equation as y1 minus y2, that is b, that is, sorry, 0 minus b upon a minus b, and equating this to the slope of the line passing through this p and b. So we'll have y minus, so we'll have the slope from the point P and A as y minus 0 upon x minus a. To after certain rearrangement, let's do the rearrangement here. So first of all, writing it in the simpler form, we have x minus y upon x minus a equals to minus b upon a. Now after dividing this equation by, say, this, taking the rearrangements, we'll here have minus y by b equals to x by a minus 1, and after taking this 1 here and y by b here, we'll have this particular form. It is the one of the very okay. After this, we move on to the next form, which is the normal form. This is a particularly the tricky, or say, a complex looking form, but I assure you it's of use to certain problems, and to the concept of the distance of a point from the straight line and other distances. To calculate the distance, we'll generally use this particular normal form. So here also what we are given is that the we are given a normal from the origin, that is of length p, and makes an angle theta with the positive x-axis. So basically we have uh, this particular angle and this particular length to calculate the line L1, which is, say, this one. So again we'll look into to find the slope of the line and a particular point to get the equation of the line. So to get the point here, we need the let's say this is the point at which normal strikes the line. We need, this is the point, so we need the coordinates of this particular point. So to calculate the point, we have this angle is equal to 90 degree, and this is the hypotenuse and the angle. So we can calculate the coordinates easily by simple trigonometry, as this will be equal to p cos theta, and this will be equal to p sin theta. So we have the coordinates as p cos theta and p sin theta. So let's write it down. We have the point P as p cos theta, comma p sin theta. And next we need the slope of this particular line. So to calculate the slope of this particular line, we note that the slope of this line is theta, and slope of this line, say, m1. So we'll have m into tan theta equals to -1 by perpendicularity of the two lines. So we'll have the slope of this line, of the original line, as minus cot theta. We'll use this particular thing in our equation. So we have slope now as m equals to minus cot theta, and the point as p cos theta minus p sin theta. So after this, it is reduced to the first form, where we have the point and a particular and the slope of the line. So by simply writing the other slope by taking the unknown point A and the point P here, we have the slope as y minus p sin theta upon x minus p cos theta equal to minus cot theta. After a simple manipulation by just rearranging the terms. We'll have the equation as x cos theta plus y sin theta equals to p. After this, we complete our understanding of the different forms of the straight line. They are basically all the same. We just need the slope and a point to find this equation of the straight line. All the equations are interconvertible. Just you have to look into what are the different features of a particular line to obtain from. Let's say we have let's try to convert one form to the other. Let's say if we try to convert the intercepts form, in which we are given both the intercepts, to the slope intercept form, in which we are given only the slope and an x-intercept, we can easily convert it by multiplying by b and taking x by a into b to the RHS. We have this particular form. Therefore, as you can see, we have converted the both the to the from the intercept form to the slope intercept form by simple rearrangement of the terms. Okay, sorry, I messed up here. This will be x. So we can easily obtain this particular expression, in which b will be the x-intercept, sorry, the y-intercept, and this particular thing minus b by a will be the slope of this line. Minus b by a will be the slope of this line. I suggest you to work out different transformations, that is convert one form of the another, that is normal form to the 2-point form, and so on, to get a feel of what we are actually dealing with.